And go.
This is Sparkyville by Group 5. My name is Jake Massica.
I'm Kevin Manan.
My name's T. Whitehair.
That's good, that's what we need.
Sparkyville, Group 5, Jake Massica, Kevin Manan, and Tate Whitehair.
Our mission for this project is to create a great way to supply energy to cities looking to go green.
The problem that we are facing is that we need a power plant that can supply the most amount of energy to power a city in a new eco-friendly way that can be transferred easily to different climates.
Another idea that we are going to accomplish is that we are going to make our power plant fold into a semi-truck to be easily transported from area to area for military use. The requirements to accomplish this project are to make it produce energy continuously, fit the client's needs, powered by clean energy, needs to be portable, no more than 2 feet tall, marketable to all areas, needs to collapse, and needs to be quiet, and lastly, blend into the environment that it is in.
Design number 1 features a watermill, windmill, and solar cells. The radius of the watermill will be 5 inches and the depth of the wheel would be 3 inches. The windmill will stand 5 inches tall and the fan blades 4 inches long. The fan blades designs are included on the bottom with the watermills. And lastly, the 3 solar cells on the top, and this makes up our design for number 1.
In design number 2, the power plant will be powered by water and solar energy. There will be a water wheel that has nearly 8 fans attached. As the wheel spins, it'll rotate the motor which powers the breadboard and then powers Sparkyville. Also connected to the breadboard will be solar cells, which will be powered by the light that is given.
On design number 3, we're placing the motor at the center of the board. The windmill will be placed on the rear edge of the board. The breadboard and solar cells will be 4 inches away from the windmill. By using these resources, we're making energy with wind and light. Our windmill blades are designed to spin by having the blades in a certain angle. The windmill will power the motor and the motor will supply power to the breadboard, as well as the solar cells will also be connected to the breadboard, which will then supply power to Sparkyville.
Our final choice is number 2. We chose number 2 as our final choice because we think it's going to be the most cost effective. We want to base it off cost mostly in case we were to mess up, so we wouldn't go over our budget. We also think that this is going to be the most efficient way to supply energy to Sparkyville. We also chose design number 2 because according to our decision matrix, it was the best one to go with.
Our decision matrix was based off of 5 criteria: the size of the design, portability, durability, effectiveness, and the lowest cost. The percentage for those are the size is 25, portability 15, durability 25, effectiveness 15, and the lowest cost is 20%. Design had a total of 36%, with the size being 75, portability 30, 100 for durability, 135 for effectiveness, and the cost is 20. Our design 2, the one we went with, came out to 150 for size, 105 for portability, 200 for durability.
As you can see here, this is our
105 for
project
effectiveness,
cost
and
or our
cost
budget.
is 100.
Our budget is $50.
For design
We would
3,
like to be a
we
good half
had
of that budget
175 for
at about
size, 75 for
$25 with all of our
portability,
supplies
75
needed.
for
In
durability.
case the
Effectiveness
rest
is
of the
60,
$25
and the
can
cost will
be
be
for
about
things that
120.
we are going to need
So
if
overall,
something
we
was
went
to
with
go wrong.
design 2 with
This way,
660 points
we
on our
can
decision
supply
matrix.
ourselves with enough time and money to make the client the best product possible. As you can see here, this is our Gantt chart. Our Gantt chart tells us when we are projected to be done with things. As you can see, we are approaching November 5th. By this time, we would really like to have almost our entire project completed. That way, come November 12th, we can test it. And we left ourselves some time in order to test things and rebuild things if they don't go the correct way, which hopefully everything will go smoothly and we will be done before the deadline.
In conclusion, we have chosen design number 2 because it fits the client's need by making it energy efficient, portable, durable, and cost efficient. We are the best fit for this project because we are dedicated and highly trained in the engineering field. We have 2 construction managers and an electric engineer.